Hello everyone and welcome back. My name is Mr. Cobalt, and in this video I'm going to show you how to calculate the change of a buffer, or the pH of a buffer, of a weak acid and its conjugate base using the Henderson Hasselbalch equation. So in the situations in which you're able to use the Henderson Hasselbalch equation are those situations where the Kb or the Ka of whatever substance you're looking at is much, much smaller than that of the concentrations that you are using in your buffer. So as long as they're vastly different, I would say on the order of like 100 times difference, it's probably it's safe to use, because then it follows in those cases, the X is too small approximation tends to be valid. It's only when the KB or KA is really close to the starting initial concentrations of your buffer is when it's probably not safe to use. And you can always validate that using the 5% rule. So here in this example, we have 0.50 molar NH3, 0.20 molar NH4Cl buffer. And in this case, the pKb of ammonia is 4.75. And so what I'm going to show you is how to figure out the pH using the Henderson Hasselbalch equation. The first thing we want to do is find the pKa, because that's involved in the equation. So to find the pKa, you have to remember that the pKb plus the pKa is equal to 14. Okay, and that's because the Ka times the Ka times the Kb is equal, or the constant, the Kb times the Ka is equal to the Kw, which is 1 times 10 to the negative 14. Okay, so we know the Kb, so all we have to do is subtract from 14. So 4.75 plus pKa gives you 14. Subtract 4.75 from both sides, and your pKa is equal to it's going to be like 9.25. So there's your pKa. Okay, so now we have to use our Henderson Hasselbalch equation. So the pH is equal to the pKa plus the log of the concentration of the base over the concentration of the acid. Okay, so we got our pKa, so that means it's going to be 9.25 plus the log of the concentration of the base. The concentration of the base is 0.5, so it's 0.50 over concentration of the acid, in this case 0.20, and then that's going to be 9.25 plus whatever the log of that is. That's going to be 0.40, 0.40, and then when you add that together, you get 9.65 for the pH. And that's it. That's how you find the pH using the Henderson Hasselbalch equation. So again, depending on what you have, if you're looking at the base and its conjugate acid, or the acid and its conjugate base, you might have to convert pKb, use the pKb define pKa. Once you find pKa, you plug your concentrations, your initial concentrations of base and acid for the buffer, plug in your pKa, solve for the pH. And again, you can use the Henderson Hasselbalch equation in those situations where the initial concentrations are vastly of your base and conjugate acid, or acid and conjugate base, is vastly different from the pKa or pKb, or the Ka and the Kb of the acid or base that's involved in your buffer. I hope this is helpful. If you like this video, please like, share, subscribe, hit the notification bell, and make a comment in the comment section. Thank you for joining me, and I'll see you next time.